Good day, howdy, hello, and welcome to the new episode of Science Nights. I'm Josh.
I'm Adam.
I'm John.
And today is all about chemistry. That's right, folks. Chemistry, the thing that's at the bottom of everything you are. It is the basis of everything in the universe, is chemistry.
Pretty much, yeah. It can be, it's the building blocks of everything, right? So.
Yep. In our biology episode, we talked about how the cell is the smallest form of life. And then cells are made of molecules, and molecules are made of atoms, and atoms are chemistry.
Absolutely.
Amen, brother.
Yeah. Who are you?
Philip.
Philip.
Oh, you wanted like a last name?
All right. Well,
Philip Goodschmidt.
Like we said, it's all about chemistry today. And first of all, let's get a good old gander at the periodic table of elements, just to kind of give you guys a frame of reference for really what we're talking about when we talk about chemistry. And we're talking about atoms, and each of the squares on the periodic table of elements represents another atom. So from left to right, we have an increasing number in atomic number, atomic weight, and then moving down as well. I mean, just looking at the periodic table right now, is there an element that calls home to you guys? Like, is there an element for you guys that you like in particular? Just random element choice.
Neodymium.
Where's that one at?
Bottom in the 2 rows, 60.
Oh, okay, with an atomic weight, atomic number of 60 and atomic weight of 144.24.
Yes.
How about you, Adam?
Nice. I do not have the periodic table in front of me, like
Yes,
John
he
does.
does.
Oh, well, thank you, but I didn't need it anyway, is what I was getting at.
Oh.
I would have to say that my favorite element out of all of them is hydrogen.
Hydrogen? The
One.
first? Yeah.
Because of the Hindenburg?
Yes, of course. You always guess it right. No.
You have to admit that was a pretty impressive fireball.
All the humanity.
So, one thing that we were talking about, chemistry being everything, and atoms making up everything, you know.
That's you, right?
Goes in line with how we had talked about in, I don't even remember what episode.
Episode 3,
anymore,
Astronomy Plus.
Exactly, how that started everything.
Yeah.
Because that's how elements formed, from protons and neutrons and electrons starting to coalesce.
And hydrogen was the first one.
Hydrogen. And that's how the first stars would have been fueled from hydrogen.
Mm-hmm.
And from them getting bigger and bigger and creating new elements inside and exploding and going supernova and sending all those elements out in the universe. That's how we all started getting
You're
built.
made up of stardust.
Slowly.
Star
That's
stuff.
exactly why
Star
we're all
stuff.
made up of star stuff. Absolutely.
We
Can
talked
we
about this
say
in episode
Stardust?
1.
No.
You can say Stardust if you
Stardust is a
want.
completely different thing.
Oh.
Yeah, it's a David
Look it up.
Bowie thing.
I'll look it up later. The only reason I said neodymium is because neodymium.
You like to say it.
Well, it's you see neodymium magnets online.
You do?
And I always thought it was a fun.
You maybe
word.
do. I don't. I've never seen a
There's nothing
neodymium.
special about it beyond that.
I bet I know what your favorite one is.
Yeah, me too.
Uh,
Something noble.
okay, how about both of you guys go? What is my favorite
guess?
element? Yeah.
Okay, I'm going to guess carbon.
Close.
Okay.
I'm gonna guess argon.
Close. Well, I mean, if we're just going off of the periodic table and what I say, Krypton.
Okay.
Because there's an actual.
I was thinking of that as like a second guess.
There's an
because of the
actual
obvious.
element on the periodic table named after Superman's planet.
Right.
But, you know, it came first. But
I
carbon
do know
is.
you're a fairly big fan of carbon.
Carbon
as
is a
an
great
element,
guess.
so.
Carbon is a atomic number of 6 and an atomic weight of roughly 12. It is what is the building block of most organic life. Everybody wants to get a piece of carbon in it.
Yep. And carbon kind of just wants everything to come into it.
Yeah,
so.
exactly. It's very
some carbon in
it's
you?
welcome
Yeah.
to the
A
party.
bit of a loose element.
Want some more?
I also think that it's important to note that humans are mostly carbon, like 95 to 97% carbon.
Wow.
There's a not famous, but there's a very popular part of Breaking Bad where a young Walter White sits in front of a chalkboard with a TA, I think, of his, and they actually try to break down the chemical composition of a human. And the first one, he's like 96% carbon, and then like he gets into hydrogen and all that stuff, and it's literally the building block of life is carbon.
But yeah,
and can be found throughout space, right?
The only life we know of is carbon-based. So yet.
Yeah, exactly. We're one there could be sulfur-based.
Those elements that we're made out of are all the most common elements in the universe too. So.
But we're the only life.
Before we know of. Before we get into any kind of history of science, I want to break down a little bit more of the periodic table as far as the numbers that you see around elements. So let's pick carbon. Carbon's a good one. Carbon has an atomic number of 6. An atomic number is how many protons are in the nucleus of the atom.
Yes.
So it means it has 6 protons. And generally, that means it carries a regular stable atom of carbon carries 6 neutrons. So 6 and 6 would be a regular kind of carbon. And then that would also mean that carbon has 6 electrons too. No, it doesn't. Carbon has 6 electrons, doesn't it?
I think you're backwards. Isn't it? An isotope is by not having electrons, right?
No, an isotope is more neutrons than
protons.
Protons.
Okay.
Yeah.
Because they don't have to be the same amount. So some regular elements have different amounts
of neutrons.
Yes, neutrons buffer out the protons. So the only purpose of a neutron basically is because it's neutrally charged. So you can't put like charges together; they'll always fight each other. So if you just had, you couldn't clump together a bunch of protons all together. You have to have the neutrons to kind of buffer it.
So the atomic number of a proton is the protons in the nucleus of an atom, which determines the chemical properties of the element and its place on the periodic table.
Yes.
The atomic weight or mass of an atom is the number that you usually see as sometimes it's twice the amount of the atomic number, but it's usually a whole number followed by some decimals. And it's the mass of an atom of a chemical element expressed in atomic mass units. It's approximately the equivalent number of protons and neutrons in the atom.
Right. It's the average out of all of the atoms of that element in the world.
Yeah. So if you hear about an isotope, that's an atom of a certain element that has more or less neutrons. So like radiocarbon dating uses carbon isotopes to determine how much. It determines how many of this specific carbon isotope is still in this form. And we know the half-life of how long it takes a certain isotope of carbon to decay.
Yeah.
So we can determine age.
Yes. All right. You're right.
Rough age.
I realized as I was researching before this episode that I don't know as much about chemistry as I thought I did at first.
Well, chemistry's a lot, right? It's not just.
Oh yeah.
It's not just chemical reactions. It's also chemical compositions. It has a lot to do with physics. Yeah. Like the interaction of subatomic particles is a lot of physics.
It's still really hard not to just conjure the image when you hear the word chemistry of somebody pouring like a little of this and a little of that and then
mustard gas.
We had a kid too. Brian in high school made a gas that cleared out the entire chemistry room and gave everybody headaches. Yeah, we had to go sit outside because he couldn't follow the lesson.
This is my favorite part of these overview episodes. And we're going to go as far back to 1627 to a man named Robert Boyle. This guy is denoted as kind of referred to as the father of modern chemistry. He was a student at Oxford where he joined a group of philosophers, and together they established the Royal Society. Eventually what Newton became a part of, and several different scientists on down the line in British history became a part of this Royal Society. He, along with Robert Hooke, aided and created vacuum tubes and air pumps. Nice. And were able to standardize temperature and pressure. And from that, we now have Boyles Law, which is when temperature is held constant, the volume of a gas is inversely proportional to the pressure. So more pressure, less volume, less pressure, more volume. But without his demonstrations on how pressure works with temperature, we wouldn't really have an understanding of how a vacuum works.
Yeah, or like how combustion or burning works inside of a vacuum.
Sure, and that led to the eventual, 300 years later, the creation of the internal combustion engine. 200 years later.
Just 200, huh?
roughly.
Like a blink of the eye.
From there, we've got Joseph Priestley, who he was born in 1733 and died in 1804. In 1774, Priestley conducted an experiment which allowed him to isolate an air molecule that he had not yet studied. Priestley repeated the experiment several times during that year and eventually discovered oxygen.
Yeah.
Nice.
Which he tested on rats, right?
Mm-hmm. Yeah.
And found that they live longer.
Yeah. He conducted several experiments with this new air using
Better
mice.
air.
Yeah.
Yeah.
He concluded that the mice were able to last longer in a tight sealed container with this new air. And he believed
Vitriolic
that,
acid air.
yeah, that this air
that
was
was-
superior.
That was
but
sulfur, sorry.
the same year that the United States went through their independence, Joseph Priestley published his academic paper discovering oxygen. So it's a little bit of, like, I like to contextualize history a little bit. That has to resonate for someone, right? Like the same year that we're throwing tea off the boats in Boston, people are like, "Hey, that thing you're breathing is oxygen."
Right. That does give it a good timeline. Like, it does help you kind of place it
Yeah.
in the scheme of things, you know, when you're
Right.
hearing just random years thrown out, because that gets a little tricky. You're just like, okay, what happened? And
From there, we've got Antoine Lavoisier, who, along with Boyle, is another one of those fathers of chemistry kind of titles. He didn't discover any new substances, but he did theorize and name things like oxygen, hydrogen. Like, because Priestley discovered the element, he didn't name it. He's like, this is
Gotcha.
just what it
Okay.
is.
Right.
Later on, Antoine Lavoisier is the one who contextualized it, called it oxygen.
Yeah.
He called hydrogen hydrogen. Antoine Lavoisier also helped create the metric system for the government. The French government was looking for a uniform way of weighing and measuring liquids and distance. And Lavoisier, along with his colleagues, created the metric system.
then we came out with standard because we're stupid.
Well, standard's not solely a part of the American history. It started in Britain, because in Britain they still use miles, and I don't even know what a stone is, but that's how they weigh themselves. Is
Yeah, 20 stone.
Yeah, that's
8
big. I
stone.
think
they
one
use
stone
miles
is like
over there?
16 pounds. Yeah,
Yeah, they do.
yeah.
Yeah.
I thought it was all kilometers on that side of the world.
No, this
Yeah,
is
yeah.
weird.
And then they
get to
like
pick and
list their
choose.
height in centimeters, which is back to,
Yeah.
it's weird.
Dmitri Mendeleev is the next man we're going to talk about, and he's a Russian. Bozhe moi. Can't.
What?
It means my God in Russian.
Okay. I was like, care to elaborate, sir?
Da.
Previous?
Dmitri Mendeleev was 1834 to 1907, and in his early years, he wanted to develop a better system of classifying elements, because people had been discovering elements here and there, talking about hydrogen and nitrogen and helium and all that stuff. And he's like, no, we've got to have a better way to determine this. So he's actually the one who came up with the basis for the periodic table.
Yeah.
And he was so prevalent in this nature of classifying different elements that he left gaps in the periodic table at the time, and they were later filled in correctly. He predicted them correctly.
Right.
That's impressive.
And it's complete now.
Mm-hmm.
But that wasn't true, I think.
It wasn't complete until like 2006.
Yeah.
It's like
I was going to say, we've
something
got
like
like,
that.
what, Californium?
Mm-hmm. It's true.
We've got some.
Yeah. You know, so like, that's a hell of a compound
But it
name.
is complete now.
Yeah.
You know. I mean, that doesn't mean. Potentially, you never know, right?
Right,
You
there could find
something. But
Maybe there's a whole
Unobtainium.
nother row
But
past the noble gases
that
we
being
don't
said,
even know
there's a
about.
few people I've heard be pretty adamant that no, it's complete and this is it. You know, so.
Yeah.
Of course, I mean that. I guess that always kind of happens.
Yeah.
Apparently, like during this time period, this guy, like, just the fact that everything was made up by atoms, people were still kind of skeptical about until Einstein proved it mathematically later.
Yeah. Like even this guy was way out there as far as thinking was. And if
Right.
you want contextualization for this guy's lifetime, he first started classifying elements in 1863. That's the middle of the Civil War.
Right.
That's 50 years before the Russian Revolution. Like this guy died during the very start
Right.
of the Russian Revolution.
And this would be back when people would still say the theory of atoms, well, it's just a theory, you know.
Yeah, that's what you were talking about.
Right.
Yeah.
Let's see, what else do we got? We can move down into Mary Curie. So this is probably one of the first women in science that we have talked about, and we should actually probably do an episode on women in science.
Oh yeah, absolutely.
But you probably know Mary Curie from her discovery of two elements and her work in physics. She got her first Nobel Prize in physics in 1903 for her work on radioactivity. She discovered radiation.
Yeah.
Right.
But in 1911 she discovered radioactivity, and that's when she was given her Nobel Prize in chemistry. In 1903 she had a Nobel Prize in physics.
And her all her stuff is still radioactive.
Yeah. She died of radiation poisoning.
Yeah.
Yeah.
Yeah, exactly.
But it wasn't just her. It was her and her husband. Let's see. They continued the work that she was devoted to the work that she and Pierre Curie started together. In 1911, Marie received her second Nobel Prize in chemistry for the discovery and isolation of radium. Yeah.
I'm sorry.
What?
You want to?
All I said to Adam was to make him lose it. I said
it's
she's
very
cute.
hard to see that.
It's a picture of Mary Curie.
Yeah.
And I said she's
he
cute.
shows me a picture. He's like, she's cute.
Hey, she was cute. I'm just so falsely. I can't help it, but I do like
Judge women based on looks.
no.
We all do.
Watch out, though,
I
she's
just meant that like
radioactive.
when you think of like a old famous woman in science, my brain just pictures like a mad scientist lady, like crazy frizzy hair, probably
Miss
a little
Frizzle?
frumpy looking.
Miss Frizzle?
Yeah, magic school bus. Is that what
Yeah,
it's called?
Magic School Bus. Yeah.
Okay. And then I was pleasantly surprised. I was like, oh.
I'm just glad you didn't say like Bride of Frankenstein or something along those lines.
I could have worked. It would have, white streak in the hair.
There are
Radiation.
just like in our previous episodes where we do overviews of stuff. There are tons and tons of different people involved in the world of chemistry that we can talk about. These are the ones that I just happened to select that I thought were interesting. But we could mention like Louis Pasteur, who decided that who found out that you can pasteurize milk by heating it. That's definitely a chemical reaction.
Brown or something. He's the Brownian motion guy that figured out that like he's seen like a piece of pollen get pushed around by other elements.
I don't even know what you're talking about.
He's the guy that made Einstein create the later then take his work and create the formula that basically proved to everybody that atoms were real.
Gotcha.
Oh, okay.
Before we get into the we're almost through like 2/3 of the show. Before we get into the last third here, we should probably mention really quick that I imagine for most of our adult viewers and listeners, they had a level of chemistry course in school. And one of the things that you would have to do would be to balance the side of the equation. You would create a chemical equation like CH4 plus H2O, and then a line that would be like the other side of the equation is 4CHF4 or whatever, and H2O and stuff like that. That is definitely a big part of chemistry. That's actually probably the most quintessential part of chemistry, and that's the reaction.
Right.
It's a chemical reaction that happens randomly in nature, naturally all the time, or humans can make it happen. One of the most recollected chemical reactions you can do is vinegar and baking soda. Yeah. The chemical reaction of those two together, you have vinegar plus baking soda equals the chemical reaction. So on the equation side of that, it would be plus and then a line and then reaction. Yeah, that's what it is. Another thing that's like a lot of people commonly point out about chemistry is table salt. Table salt is NaCl, sodium chloride. The combination of those two elements creates the molecule sodium chloride, and that's our table salt. That's as simple as it needs to be. And I mean, now we could probably get into like, what is your favorite aspect of chemistry? Like, what do you guys enjoy about chemistry? What do you think is interesting, mind-blowing, boggling?
You know how we said it conjures that image of people mixing chemicals, and that's always been my favorite part. Like
Really?
the actual experiments.
The mad scientist kind of.
There's
image
just
of,
something fun about not just that, but like the precision involved, like the heating of chemicals and stuff like that, and like
Cooking
everything.
meth, yeah.
Well, just the really cool equipment they get to use, and like to me, it's always seemed just super fun. Like that's always an enjoyable thing.
Any
Like, when
excuse
we
to
were
get the Bunsen burner out, right?
Dude,
Yeah.
every time we were in chemistry class, I'm just like, experiment time. Like, done
Yeah.
talking, let's make something happen.
Did you ever have like a chemistry set or anything?
I did when I was a kid. I also had a microscope and all kinds of crap.
Yeah.
I looked at my own blood.
Like how it's
I
like
all kinds-
crap, but it's actually really, really interesting.
It is. No, I had a lot. My dad used to get mad at me because I always wanted like cooler stuff. Like I got this really crappy microscope, and I think it was like 100 times
Yeah.
magnification, and I wanted a better one. And I was always showing him pictures of the better one I wanted, or like this one, and the prices were just.
Yeah.
And
yeah,
then my
microscopes
dad
are
just like
expensive,
look
sure.
at him and be like, "Keep dreaming, kid, but go ahead outside and look at another blade of grass." Like, and I had like all the little slides in the little glass covers. I cut my finger on a glass cover and then used it to look at my blood because, well, we're here now.
Bringing up the Bunsen burner thing and the making an experiment thing in chemistry, that is part of like you can just have a molecule put together. Like you just have that NaCl, and you add heat to it. That's gonna change how that molecule is together. I don't know if it actually does
Interacting
that.
with each other and
Yeah,
stuff,
but it'll split it. It'll add oxygen to it. You can add carbon to it because of the heat. There's lots of things that could happen, and that's all chemistry.
Now,
Another thing. Go ahead.
oh, I was gonna say I don't want to confuse people by bringing this up, but like,
But you feel compelled to anyway.
I was just gonna ask you guys. So like with alchemy,
Okay.
which is
What
has,
chemistry
like,
became.
Yeah.
Early stepping stone to chemistry. Yeah.
exactly where they're like trying to create stuff through chemical
Right.
combinations.
Yeah, like put my brother into a piece of armor. Yeah.
Yeah,
totally.
or
There's
like-
people messing with these strong chemical reactions, but not really knowing what it's doing.
right, like I'm gonna make gold, and I'll just pour some of this and that and this and that, and shoo, nope.
I'm gonna make
gas.
I'm gonna make gold out of lead. Oh, I just discovered radioactivity.
So it's basically like
Yeah.
when we were kids playing with chemistry sets, didn't know what the we were doing, we're just mixing shit
Yeah,
together.
it is like a rudimentary chemistry.
Yeah.
But sorry, I don't know.
What was your question?
Well, I don't even remember anymore. I was just bringing up alchemy now because like
That's
I can't-
fine.
So just,
You know, in
you
Newton,
just like that aspect of it.
Yeah.
in Newton's later life, he wanted to be an alchemist.
Yeah. He kind of, didn't he almost like denounce the stuff that he did? Or just that it wasn't, maybe not denounce it, but that wasn't really very important. This is important.
Yeah,
though.
yeah, like his stuff on the laws of motion were unimportant to him compared to like he's like we can unlock the entire secrets of all of nature if we
Right.
can understand alchemy.
Yeah.
So there's nothing wrong with having an interest in alchemy. You want to make something from another thing. That's awesome.
Like,
let's see if that's
I'm
a
gonna pour
thing.
orange juice and milk and make a cheeseburger. We'll see what happens. No.
I mean,
You should work on trying to 3D print a cheeseburger.
I mean, I think that's possible.
That is
I
more
just don't
possible,
think it's
so.
edible.
I mean, it could.
Hey, I want mine to be
There's a difference
gluten-free.
between edible.
Do you guys have
and
any more of
good.
that beef filament for my 3D printer? I'm fresh.
no,
out.
you do it with
Just
the
straight
liquid
protein.
one. You do it with the liquid one.
I had a history teacher that once said, one day it'll be like Star Trek, and it will just pull all the molecules out of the air.
Dinner?
Yes.
Yeah.
It was dinner. And he was like, and we'll be able to just make a cheeseburger. And I was like, there's not beef molecules floating around in the air.
No, but I mean, think about it this way: if you could potentially replicate it exactly at an atomic level, you could.
That or what if
But I
you
mean,
what if you
just
had a
like
device?
everything's readily available right around you in the air, like nothing has to be sought out. We have or would you just be rearranging atoms and neutrons and molecules?
You would
so
need
you
matter.
Would assume
You
that
would need
Star
matter.
Trek has
Matter,
the
yeah.
ability to, in the Star Trek universe, they have the ability to alter the atoms as they want, right?
Okay.
Like they can create whatever atom they want. As long as they have a few fundamental things on board, then they can create pretty much anything.
Yeah, all you need is the matter. You don't necessarily need the active ingredient in the air.
Right.
At least,
Well,
at
I
least
mean,
in the
But I
terms
just
of
mean I just meant enough of the pieces in the air.
Right.
But that makes sense if you can alter them.
So
then
if
you
you
can make them.
if you split a hamburger up into atoms,
Into its component
and then
parts.
analyzed each atom, and then replicated each atom and put it all back together, it'd be the same.
Yeah, we're like
you ever see
halfway
Willy
there.
Wonka? Ever see Willy Wonka when they make the big candy bar little with the TV thing that they do? Same thing. Same thing.
Same.
So it's the same as like teleporting.
Yeah, they rearrange molecules and put them back together.
I believe it was a hydrogen atom that they recently teleported to ISS or
I have no
into
idea.
low Earth orbit.
You're in a different realm.
Teleport. But that's just one single atom, right?
Yeah.
And
We're a little more
at
complex.
one point, and I may be wrong. Maybe they haven't done it yet, and it was a thing they were going to do because we've managed to do it short distances,
Yeah.
right? It's like you could teleport a hydrogen atom like a mile or something like that, which is obviously it's not very far and it's not
Robust.
It's right because it's just one atom. That would
It's the smallest
what
atom.
it would entail to teleport a human would mean you would have to replicate every single atom in their exact states
Yeah.
perfectly. You know, one out of place just up the whole thing. You know.
What other, to bring it back to chemistry, what other elements of chemistry do you find exciting?
The amount of power there is in an atom, right? So like the strong nuclear force is the strongest of the universal forces of nature.
So what
Those are
Adam's
the
talking about
four-
is what
the four
keeps
forces.
an atom together, what
Right,
keeps its
it's what
protons
keeps those
and
protons and neutrons together,
Yeah.
right? Which is what makes it so difficult.
To
We
split it.
figured out fusion, but you see what can happen with a fusion when we split an atom.
That's fission.
It's fission. Yes, sorry.
Fusion's
yes.
bringing it together.
Absolutely, fission is taking it apart. Fusion is we can do it, just not efficiently. But
Our input is greater than the output for
right,
fusion.
right. But you
Yeah.
see the devastating power you can have by just splitting an atom. So.
Yeah.
The first fission bomb was dropped in Japan in 1945, and the second one was dropped in Japan in 1945, and we haven't dropped a fission bomb since because now it's all hydrogen bombs.
It was Hiroshima and Nagasaki, right?
Yeah, they're both Japan.
Yeah, no, I'm just naming those two
Yeah,
places that
yeah.
were dropped.
But the sheer devastating force, it was like 100,000 times dynamite or something like that. Like
Yeah.
it was ridiculous, and that's what Adam means
Have
by
you-
the strong nuclear force. It's so powerful that just splitting it creates that massive output of energy, which is astounding, and I do agree.
I've always wanted to go to the nuclear test sites that they have out in the desert. Where
So
they have,
if you watched our first episode, when you mentioned that, I put a picture up of that glass.
yeah,
yeah.
I've always wanted to go see that though.
It's in Nevada.
Yeah, I think it would be crazy to see that where the so hot and the sand
either that or New
literally melted
Mexico.
in the glass in like a big sheet.
Right.
That's just crazy to me. Like,
What I find most interesting about chemistry is that it regulates all of biology. So if you recall our first episode, I chugged that water. No, actually, biology, I chugged the water.
Yeah.
That was not only adding H2O into my system, but it was also balancing the salt content in my system.
we
which
were
is
worried about
Na.
you drowning.
Yeah, exactly.
He was safe.
There's potassium, which regulates a lot of your body's systems that you need. If you can also overdose on potassium and kill yourself.
Right.
Yeah. But
There's
if you don't have enough, you'll literally puke blood. So
there's
maybe eat a
hemoglobin
banana.
in your blood that is that contains iron in it, and if you have a lack of hemoglobin in your blood, you're usually a hemophiliac. You have problems with your blood, but if you have an overabundance of iron in your blood, you also have a problem there. And then also a lot of the chemical compositions in your brain, your neurotransmitters and your synapses are based around serotonin, melanin, oxytocin. A lot of different chemical compounds affect your behavior directly. I mean, if you don't have enough melanin in it's either melanin or melatonin in your body, you have trouble regulating your sleep. If you have too much serotonin in your body,
It's
melatonin.
melatonin.
Right.
Melanin.
Melanin
is
is
the
your
color of
skin.
your skin,
Yeah,
my bad.
it's to protect your skin.
Now
from
this is
UV.
black and this is blue.
Yeah.
That's
Because like melatonin's one of the few sleep aids you can use without like
Yeah.
dependency issues.
Yeah.
So it's just over the counter,
And
and
then-
it works good.
So, if you know that serotonin, oxytocin, melatonin affect your body normally and it regulates your body normally, and then imagine how it affects you when you take a substance that mimics it, overstimulates it, inhibits it. I'm talking about not only about narcotics that do that, because like for instance, morphine overdoses you essentially on serotonin. Like you go overproduction of basically the feel good chemical.
Right.
But then there's also
Happy
inhibitors
juice.
that what?
Happy juice.
Yeah. There's also inhibitors that stop production of serotonin or stop the production of oxytocin, and those are often found in like antipsychotics or mood suppressors or things like that. So
Well, you even have finite levels of those chemicals in your brain that can be released, and you can actually.
what is that, DMT or whatever that does that?
Yeah, you have DMT
Even
in
as
your
simple
brain.
as like mushrooms. You do too much mushrooms consecutively, you run out of the old happy juice, as it were, to keep things simple. Not forever. Your body produces more, but you could find yourself in a moderately like depressed / unenthusiastic state
Absolutely.
from just using it all up. Like there are limits to those things that the body can produce and hold at any given time.
So that's what I find interesting about chemistry is just
Yeah.
on the, I don't want to say lowest, but on the smallest scale, it regulates all of your biology.
Yeah.
And that's from psychology through to just physiology. It's incredible. And I mean, Stephen Smith rightly pointed out a little while ago to us that every discipline in science is interconnected. And chemistry is a great way to demonstrate that.
Yeah. Absolutely.
Before we go, we got probably a lot wrong tonight. And
I don't want to go.
we want to know about it. So if there's something we got in error, please, it's science job to peer review itself. So let's hear some peer review.
It would be. We should do this for most of them. Like I don't know, a year from now or something. Go back and be like we just did. What's our favorite thing about chemistry? I bet that changes a year.
Oh,
from
for
now.
sure. Yeah.
We actually know more about it. Than,
Right?
You know?
Like,
Absolutely.
I think I'm gonna have to Khan Academy some stuff.
Yeah.
I really like Khan Academy.
But like I said, we're open to correction and criticism. Please let us know. That's the point of this. And be sure to check us out next week. We'll have go ahead.
Chemistry is way too vast to cover
On
all
one
in,
episode, no
Oh
way.
God.
We could probably
You couldn't
spend.
even cover one small part of chemistry.
Yeah.
I would like to do an episode on just the noble gases, on just on just isotopes, on just radioactivity.
Yeah.
Yeah.
That'd
absolutely.
be great, because that would be physics and chemistry. So before we go, I have a little tease. Next week, on the next episode of Science Nights, we will be talking to a chemist from JPL, the NASA's Jet Propulsion Laboratory.
Very nice.
So on that note,
and he's an actual chemist, so he probably would listen to this and be like, "Dude, you guys
so wrong.
You guys don't even know." what
I
I'm
really hope he
talking
does
about."
listen to it, and then we
Laughs
can
at us a little
retroactively
bit.
correct ourselves.
Yeah, no, it's good though. We need to if we are incorrect.
Yeah.
Because that's not the plan.
John, thanks for joining us again.
You're welcome. Thanks for having me.
And we'll see you guys next week on Science Nights. Goodbye.
Bye.